Hi girls. Okay, so yesterday I put up a YouTube video and it goes through the entire chapter as such. It's great as an introduction and then it's great again at the end. And I would have used it actually even before online classes because that particular website, Khan Academy, has lots of great stuff on it. And as you come into next year, we'll be using it a little bit more. Okay, so the first thing that I'll reiterate again, what does the word similar mean? So if I said to you, we'd say, Emily and Alice, you have something in common, or you girls are similar. What would I mean by that? What I mean by that is I have something that I can pick that's in common. So I'm trying to remember. I picked Alice and Emily. I don't even know if you have the same colour eyes, girls. Maybe the same colour hair. Maybe I could choose two people who like the same sports, or I could say, for example, I have two Leahs in the room. I could pick the two Leahs and say, well, you girls are similar. And you would say to me, well, what do you mean by that? How are we similar? Well, your names are the same. So you have something that connects you and makes you similar to somebody else. I could say everybody in my maths class are similar. And what I mean by that is you all have something in common. Not that you're identical, but that you all have your own individual personalities, but that you are similar. Okay, so if I take a look at these two triangles, clearly I can see that the two triangles are not the same. They're not identical. And then as I look at those triangles, I try to point out things that might make them the same. So let's say if I measure this angle, this one's 100. This angle's also 100. This angle is 50, this angle also 50, and this angle's 30, and this angle's 30. Okay, so if I wanted to colour code it, I could say this is the orange angle. I have a yellow angle, and I have a non-colour angle. Okay, sometimes they'll use little shapes to say this angle is the same as this angle because they both have one tick. This angle is the same as this angle because they have two ticks. And this angle is the same as this angle because it has 3 ticks. So I have loads of different ways of saying to you those angles are the same. Now these triangles have something similar. The thing that they have similar is that all their angles are the same. Okay. So if I was to label this angle A, B, C, I could call this one A, B, C. Okay. It'd get confusing because I'd have two ABCs triangles. So what I might do is I might call this one X, Y, Z. And again, why would I do that? Well, why would I ever call two people something different? Like if you have brothers and sisters, why don't you all have the same name? Because when your mother's trying to shout up the stairs to get somebody to bring down something from upstairs, she wants to know which ones she's shouting at. Does that make sense? And I don't mean shouting in a bad way. I'm just trying to give you reasons why you would have different names. But what I could say is that the side AB will have something in common with XY now. And it's in common. It's not identical because you can straight away see by looking at these two triangles that AB is bigger than XY. But they're going to have something in common, and that is going to be their ratio. Okay, their ratio will be the same as the ratio between XZ and AC. So AC will have the same thing in common as XZ because those sides are the same, as BC will have something in common with YZ. Okay, so let's say this one was 8, this one was 4, and this one was 6, and this one was 3. If I said to you, this one is 10, what is this side? And some of you can already see that. So if I look at this side and this side are common, what's 4 and 8? So I would say AB, so that's 8 divided by 4, that's 2. If I look at these two, I'd say 6 over 3 is also 2. So 10 over something must be giving me 2. What do I divide 10 by to get 2? It's 5. Okay. What we're saying is that each of these sides are halved, or each of these sides are doubled. And that is a type of ratio or comparison that makes the two triangles similar but not identical. There's lots of different ones that you'll take a look at and you'll see. So the example that I've kind of done is kind of two similar examples that you've got in the other side. Let's see if I can pick out a question that you might have here. So they've used colour coding. So let's see, a red, a blue, a green. So they've a red, a blue and a green. So I'm just trying to pick out a triangle, and on the other side they have a red, a blue and a green. And what they've said to you is, you know the way sometimes we taking things from two different places, girls, like I always do. Anyway, this angle is the same as this angle, and this angle is the same as this angle. Okay, they've labelled the triangles ABC, so A, B, C, and the other one is Q or S. Q or and S. Okay, so triangles are not the identical. Straight away I can see that. But they must have something in common. They've told me that this is 40 and this is 16. And they've told me this is 5 and they want to know this. Okay, so my first job, I suppose, is to match up the ones that belong to each other. Okay, so X and 5 belong together and 40 and 16 belong together. And it's really important now that I put them in the right order. So my question to you when you straight away look at it is this number going to be bigger or smaller than 5? And you should be able to see by looking at the triangles that this side is bigger. Okay, so we want to find out how many times bigger is it. So we have 40 over 16, and we type that in to the usual missing calculator, girls. 40 divided by 16, and we see that that's 2.5. So this side X is going to be 2.5 times bigger than this one. So 5 multiplied by 2.5 5 will tell me that that side is 12.5. And again, I stop and think, does it make sense? Okay, let's look at it again. Are the two triangles identical? No. Do they have things in common? Yes. They have two angles that I'm shown are the exact same, which means that this angle must also be the exact same, because all three angles of any triangle always add up to 180. So if the three angles the same as up here, so therefore the sides must have something in common. Not be identical, but something in common. So which sides match each other? Well, the two orange sides match each other and the two black sides match each other. This black side is going to be bigger than 5. So that tells me whether it's a multiply or divide. If it was the other way around and I'd been given this one, whatever answer I would have gotten, I would have divided it by the 2.5, okay, to get this answer back. So you have to decide if the side is bigger or smaller, and by deciding whether it's bigger or smaller, you can decide which you need to do. Okay, so you're going to start and take it easy, and let's see how you can get on. Identify the sides that are the same first of all. So you're going to look at page 158, and you're going to look at question 1 first of all, and question 2, and you don't need to do all of these. We'd say A and D, and question 3, A and B, and question 3, A and B, and that's on page 159. Okay, and let's see how you get on with these ones. Okay, and I'll talk to you soon. Take care.